All right, we'll go ahead and get started. So first thing I want to do is pull up Google Classroom. That way you can figure out where everything is that we are working on. So give me 1 second. Get the pull tab. There we go. Okay, so if you go into your Google Classroom, we are on Unit 3, Week 1. So everything for this week you can find right here. These knowledge checks will be done in class, so you don't need to like work ahead and work on them. That would not be helpful to you, okay? So we're gonna start there. So Unit 3 slides is what we're gonna work on right now, and then eventually we will get to a knowledge check. I probably need to open this in my Google Drive, maybe. Hang on 1 sec. Well, we'll see if I can do it this way. Okay, so essentially we're going to be working on the same things that we already talked about. So intersecting, parallel, and skew, lines and transversals, parallel lines and proofs, properties of parallel lines, constructing parallel and perpendicular lines, and then we'll have some sample questions towards the EOC, towards the end of this unit. So this is a broad overview right here of the whole unit. So the first thing that we're going to talk about is corresponding. Then we'll do alternate interior, alternate exterior, which are all things that you've already done. So this should be a breeze for you compared to what you've been doing because you've already been introduced to it. So the first thing that we have are lines, and we're going to talk about intersecting, parallel, and skew. So back to kind of where we started at the beginning of the school year with Euclid, we've gone over many of his postulates. We've already gone over 1 through 4, and now we're looking at his 5th postulate. And so Euclid's 5th postulate says that if a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side of which the angles are less than 2 right angles. Whoa. So that makes no sense. So we're going to spend the next few slides kind of breaking it down on what this means to us, like in English, for non-mathematical people. So Euclid's 5th postulate is perhaps the most famous, and it's bothered mathematicians for years when they're trying to figure it out. So again, here is the 5th postulate. And to Greek philosophers, it seems so natural that Greek geometers thought they should be able to prove this 5th postulate. And they resisted using it for years because they couldn't figure out how to prove it. However, they eventually did figure it out. So Euclid's 5th postulate, and this kind of looks really similar to like what we've been working on. You'll notice these angles here. They kind of relate to the angles that we've been working on in class previously. So the 5th postulate says that there are 2 possible causes if one line crosses 2 others. Can somebody tell me in the chat what a line that's intersecting 2 other lines is called? What is a line that's intersecting 2 other lines called? We went over this already.
Perpendicular?
In this case, it is creating perpendicular lines, but there's a word for it that starts with a T. And it's so that blue line right here, what would the name of that blue line be? It starts with a T. Any guesses? It is a transversal. So a transversal is the blue line in the picture, and that is a line that is crossing over 2 other lines. And a transversal is kind of the basis of what we've been doing these last few times. So Euclid's 5th postulate says if the pairs of angles on either side of the blue line, say 1 and 3 or 2 and 4, add up to 180, then the 2 red lines will never meet. So what they're saying right here is if you add angle 1 and angle 3 together and they equal exactly 180 degrees, that means that the 2 lines are parallel. And so all angle pairs, in order to solve for them, you're going to be dealing with parallel lines. So these red lines right here, we know that they're parallel because if you add angles 1 and 3 together, you get 180 degrees. When something is parallel, that means that they're never going to intersect. So you can also take your transversal. So notice your transversal in this one is creating perpendicular lines, right? Okay, because it's straight up and down. They tilted the transversal in this picture. But what you'll notice is that 1 and 3 are still going to add up to be 180 degrees. Okay, and 2 and 4 are also still going to add up to be 180 degrees. In this previous picture right here, these were creating 90-degree angles. So 90 plus 90 is 180. That was easier to solve just by looking at on the first basis. But if we look at this next slide here, angle 1 is less than 90 and angle 3 is larger than 90, but together they're adding up to be 180 degrees. And when that happens, we know that the lines that are being intersected by the transversal are parallel lines. So in this case, these red lines are parallel. And they're parallel in this picture, and they're parallel in this picture. It doesn't make a difference if the transversal is slanted. Okay, so Euclid's fifth postulate says that if the angles on one side of the blue line add up to more than 180 degrees and the angles on the other side to a sum of less than 180 degrees, the lines will not meet on the side. Sorry, the lines will meet on the side with the smaller sum. So if you kind of just like look at this picture, it actually makes sense because it is slanted, and you'll see, and I can draw it for you. That might help you kind of see. I'll even draw it in red just to go above and beyond. So if we were to extend this line right here and keep it going, granted, I'm not very good at holding my pencil steady. It's going to keep going like this, right? And this one will keep going here. And this one's going to keep going here. And eventually they will meet. So Euclid's postulate says, I'll read it one more time, that if the angles on the side of the blue line add up to more than 180 degrees, and the angles on the other side have a sum of less than 180, the red lines will meet on the side that has the smaller sum. So he's saying that the red lines are going to meet on the sides that's less than 180, which makes sense because that one is slanting downward. So the line that's headed downward is going to eventually hit this line. Questions on that? It's like a little bit new, and I don't want it to be confusing. Okay, so here's another example. If we look at this, this red line is slanted, okay? And so if we continued on with these lines, what would that look like? So we continue on right here. Oh, I'm gonna use the fat one because it makes my drawings look a little better. Not much, but a little. So if we wanted to continue on, this one's gonna keep going here. And eventually they will cross. We know that these red ones are actual lines because of the arrows. If they were line segments, they wouldn't have arrows. So notice here, Euclid has told us that since this is the side that the two angles, which we're talking about, these angles right here, these two angles are less than 180 degrees, which means that those lines are not parallel and they are going to intersect. And they'll intersect on the side that's less than 180 because it's slanted that way. If you guys have any questions, just feel free to interrupt. Okay. So Euclid's fifth postulate. They couldn't prove this from the other axioms and postulates, but without it, there were a lot of important pieces of geometry that they could not prove. So they gave in and made the final postulate of Euclid's geometry. For thousands of years, therefore, mathematicians felt the same way. They kept trying to show why this postulate was not needed. No one succeeded. So if you think about something that you've probably been trying to prove for years, you're a little passionate about it. Maybe you've been trying to figure out how to ride a bike or to swim or how to cook or something like that. Anything that you work on for a long time, you're passionate about. So with this being the case with mathematicians, they were super passionate about figuring out how to solve for this and determining what the postulate was because they'd been working on it for years. So here we go. In 1866, Bernhard Riemann took the other perspective. For his doctoral dissertation, he designed a geometry in which Euclid's fifth postulate was not true, rather than assuming it was. So previous to this guy in this picture, everybody thought that Euclid's fifth postulate was true and that they just couldn't prove it. Well, he decided it wasn't true. So this led to non-Euclidean geometry, in which parallel lines always, rather than never, meet. So up until this point, we've all been saying that parallel lines never meet. And this guy, Riemann, is challenging that. But a half century later, non-Euclidean geometry, based on rejecting the fifth postulate, became the mathematical bias of Einstein's theory of general relativity. So that is a picture of Einstein. Doesn't look like the picture of Einstein we're used to seeing. But Einstein played a part in geometry, which I'm assuming that we all know what geometry is, right? So Einstein's theory creates the idea of curved space-time, and this is now the accepted theory for the shape of our universe. So when we look at the world, it is a circle, and Einstein is responsible for determining that. Obviously, he's not responsible for making the world, but he is responsible for the globe-like situation that we find ourselves in. So now we're going to kind of backtrack and look at this prior to non-geometrical, prior to this man, Riemann. Okay, so he's out. His ideas got thrown out by Einstein. So now we're back onto this parallel lines never meet, because they don't ever meet. So talking about parallel versus perpendicular versus intersecting and all of those. So in the chat box right now, can you type one thing that you know about parallel lines? Only one. Don't hit send. We'll send it all at one time. So in the chat box, you're typing one thing that you know about parallel lines, and I'll give you 1 minute to do that. We've learned a lot about them. So you're typing one thing in the chat box that you've learned about parallel lines. Yeah, so you don't have to send it right now. But all right, everybody else that types something, go ahead and hit 1, 2, 3. Good job. Okay, I love that. They go on forever. They never intersect. They never cross. They never meet. All of those things are really great qualities of parallel lines, and that's important. So parallel lines do go on forever. If they were parallel line segments, they would not go on forever. But since we're talking about parallel lines, that is perfect. The biggest thing is that parallel lines never meet. So if we look over here at the formal information, in the blue lines that we see there, those are parallel. And those are lines that are in the same plane and they never meet. They're called parallel. Then below in red, we have intersecting lines. And those are lines that share a single point and they're called intersecting lines. Intersecting lines are coplanar. Okay, so they're on the same plane. So questions about that? What the difference between parallel and intersecting lines are. The biggest thing is that parallel lines never meet and intersecting lines meet because they intersect. Now we're going to talk about skew lines, which we learned about all of this like previously, like basically right after Thanksgiving break. And so skew lines are lines that are in different planes that never meet are called skew. So if we look at this picture, you see a red line and a blue line. Lines M and N in the figure are skewed. Why are they skewed? Well, if we were to look at this and kind of really break down what's happening here, this blue one, this right here is one plane. So I'm going to outline this plane. Okay. And this red line is all on this blue plane. Yeah, this red line right here, it'll keep going, but it's going to go this way. And then it's going to go, it won't hit the yellow plane because this is technically a three-dimensional figure. It'll like go down towards your floor. Okay, so you're looking at something like this. So this red line's going to go like this, and the blue one's going like this. So then we have this yellow plane right here, which is right here. And this blue plane is going to like shoot through there and go this direction as well. They are never going to meet. Okay, so lines M and N in the figure below are what we would consider to be skewed. Okay, we'll talk about skew lines in more detail later on in this presentation. Essentially, skew lines don't make sense. They're not parallel, they're not perpendicular, they're not on the same plane, and they're not going to touch. They literally don't have anything in common. So if we want to backtrack and talk about the parallel postulate, one way of restating Euclid's fifth postulate is to say that parallel lines never meet. An extension is the parallel postulate. The parallel postulate says, given a line and a point not on the line, there is one and only one line that can be drawn through the point which is parallel to the line. What? So can you imagine where the parallel line would be? So if we were to take and draw this. Oh, will this help me draw a straight line, do you think? Oh my gosh, it's going to draw a straight line. So if we had this line, like if our line on B was going this way, I wonder if I can change the color. wonder if I change it, will it like not let me grab it? No, it doesn't work. Hang on. Okay, let me try this line plan one more time. Oh, I can put an arrow on the end of this. This is so fancy, guys. Sorry. Okay, so if I was to hit at B, they want to know where we can draw a line that will be parallel, right? So can you imagine where the parallel line would be? Well, it wouldn't be here because that's going to intersect. And although right in this actual picture, these two lines that I have are not touching, eventually it will touch because that other line is going to expand. So the only way would be pretty close to like right here, okay? And how would we know that? Well, if we were to take another line and draw it through B, the one that's parallel to it would have to be create a 90-degree angle right here, which would mean that they're never going to touch. So technically what I have drawn is actually not parallel because I didn't measure it, but it was pretty darn close. So continuing on with the parallel postulate, can you imagine any other line which would be drawn through point B and still be parallel to line A? Is there one? What do you think? No problem, Kristen. So in the chat box, what do you think? Is there another way we could draw line B, that red line, and make it still be parallel? Go ahead and type yes or no, and then we'll all hit send at the same time. So can you imagine any other line which could be drawn through point B and still be parallel to line A? And you're typing either yes or no in the chat box, and then we'll send it all at one time. All right, ready? 1, 2, 3. I got one answer, guys. Antonio, where could we draw another line and make it be parallel? Am I about to be proven wrong on the next slide? I don't think so. Guys, we need more participation than this. Come on, people. So the answer would be no. B right here, this red line, is the only way that you could draw it. Because even if you tilted it just like a little tiny bit, since those are lines and not line segments, they would eventually intersect. So parallel, intersecting, and skew. Parallel lines are two lines in a plane that never meet. We would say in this picture that line DE and FG are parallel, or symbolically. So let's talk about what each of these abbreviations means. So this one right here, that tells you that DE is a line, okay? If it didn't have arrows on the end, it would be a line segment. So this is telling us that DE is a line. And then this right here means parallel, okay? So they're saying line DE is parallel to line FG. There's a reason we use these abbreviations, because if we didn't have that above it, you might think it was like a line segment, or it could be a ray or something like that. So it's important that we're labeling things when we're describing them. So in this picture, it's telling us that line DE is parallel to line FG. So DE is parallel to FG. So how do we indicate that lines are parallel? Lines cannot be assumed to be parallel unless it is indicated that they are. Just looking like they are parallel is not sufficient. There are two ways of indicating that lines are parallel. The first way is to announce it. So they are announcing that they're parallel based on right here. Oh my gosh, it's really hard for me to use that thin one. Based on right here. Okay, so this is telling us that they're parallel. There is another way, which we'll talk about on the next slide. Oh, hang on. Trying to let somebody in and draw at the same time does not work. Okay, so another way to indicate that lines are parallel, and we spoke about this right after Thanksgiving break when I showed you a picture of parallel lines. So the other way to indicate that lines are parallel is to label them with arrowheads as shown below. The lines with the red arrowheads are parallel. If two different pairs of lines are parallel, the ones with the matching number of arrowheads are parallel as shown on the next slide. So when they're saying arrowheads, they're talking about this right here. Oh my gosh, hang on, I need to think. I wonder if I set that to be my default. Talking about right here and right here. So when there's arrows like that, that means that the two lines are parallel. You also could take a ruler and measure. And if you measure the distance between here and here, and then say here and here, here and here, here and here, they should all be identical distance, all of those lines, because parallel lines never meet. So indicating parallel lines. The figure below indicates that lines K and M, which are the red lines, are parallel. It also indicates that lines A and B are parallel to each other, okay, which are the blue lines. But lines K and M are not parallel. So if you'll notice, to indicate that the blue lines are parallel, they have 2 arrows, okay? And then to indicate that the red one is, they just have 1. So there's a reason. So if we had taken, now that I know how to draw a line, we could, oh my gosh, we're gonna get really fancy here. So we could take this line right here and this line right here, which obviously there's not gonna be perfectly parallel because I'm making them up. And we could, if we want to note that these are parallel, you could just go like this. And this time there's going to have to be 3 because it's another set. Okay, so notice the red ones each have 1 set of lines, the blue ones have 2 sets, and the green ones have 3. So there's 3 different sets of parallel lines in this picture, and each one is denoted differently based on the number of arrows that are on that line. So parallel, intersecting, and skew. 2 distinct lines in the same plane are either parallel or intersecting. If the lines intersect, they do so at one point. If 2 lines intersect, 4 angles are formed as shown. Okay, so we know that 2 lines that are intersecting, 2 straight lines, can only intersect at one point. And I think we learned about that like the first week in August. That was one of the very first things that we learned. So intersecting lines can only intersect at one point. And when they do, they are forming 4 angles. Well, what does that look like? So we end up with this one and this one and this one and this one. So all of those angles are formed by those intersecting lines. Okay, so those are 4 angles. And I believe we've like kind of already talked about how we can solve for these angles. So let's kind of add a little bonus into this. So if I tell you that this angle was 120 degrees, if angle 1 is 120 degrees, so we're kind of practicing, what would angle 3 be? And what's our vocabulary word that helps us with that? Go ahead and type it in the chat box.
Angle 3 would be 120 degrees because they're vertical angles, I think.
Yes, bingo, great job. Okay, how could we find what angle 2 is?
Take 180 minus 120 and you get 60.
And like, what is a vocabulary word that we would use to describe how you knew what to do? Like, how did you know that those add up to 180? They're on what? I might have confused you with my question. So he knew to take 180 and subtract out 120 because those are both angles 1 and angle 2 are on a straight line. What do you know about angle 2 and angle 4? What would we call those? Angle 2 and angle 4. There's a vocabulary word to describe them. What is it? So Naily, 1 and 2 are supplementary. 2 and 4 are directly across from each other. So what do we know about 2 angles that are directly across from each other? Yeah, they're vertical angles. Great job. So we know that this is also 60 degrees. Perfect. So Naily, you brought up a really good point though, right here. That's the word I was looking for. Let me re-outline it and show you. So right here, these are supplementary or linear pair, either way. That's how we knew that it was going to equal that. So look at how much you already know. Like, you already know how to solve for all of this. So linear pairs, again, consider the 4 angles labeled 1 through 4 and the figure below. Pairs of adjacent angles are called linear pairs. 1 and 2 are linear pairs because angle 1 and angle 2 add up to 180. Look at that. You guys already did that on the previous slide, so go you. 2 angles that form a linear pair are supplementary. Naily, look at that. You already even told me they were supplementary. So what we've been doing up until this point, like all of that comes together in unit 3. So now we have a bunch of proofs, which we are not going to do proofs because of online learning and all of that. But essentially what you did up here when you solved for this, that is a roundabout way of doing a proof, okay? So skipping that. Skew lines, heading back to skew lines. So we're going to re-go over this right before your knowledge check, which is what we're doing right now. So skew lines, if two lines intersect, they define a plane, hence they are coplanar. Lines P and Q lie on the same plane, and they're on plane U. Two lines that do not intersect can either be parallel if they are in the same plane or skew if they are in different planes. Lines M and N in the figure are skew. Okay. So does anybody have any question on like what skew means versus intersecting versus parallel and perpendicular? I like to just say that skew makes absolutely no sense with it, like at all. Okay. Skew lines are not parallel, they're not perpendicular, they're never going to touch. Like they don't make any sense with it at all. And so in this picture is where you see skew. So talking about skew lines on an actual like cube, consider HG. Using the diagram, name a line which is skew, a line that does not lie in a common plane. How many skew lines? Do you guys remember doing this before? I was like teaching you ahead. So like this would be skew right here, okay, because it's not parallel, it's not perpendicular, it's never going to touch, okay. Another one that we could call skew would be like over here. And we could say that this one is skew because it's not parallel, it's not perpendicular, it's never going to touch. You also could say this one would be skew. So this would not work. This is not going to work because it touches it. This does not work because it touches it. This does not work because it's parallel. This does not work because it's parallel and it's on the same plane. This doesn't work because it touches it and it touches it. And again, this doesn't work because it's parallel. Okay. Questions on skew? No? Oh my gosh, look at that. They outline the same ones that I did. So there are 4 skew lines in this picture. So just kind of sit with that for a second. And then we're going to take a knowledge check. All right, so if you go into Google Classroom, there is a knowledge check, and let me see, it's one. Okay, so it's called Skew Lines 1 through 7. I will give you guys until 1:45 to do, sorry, not 1:45, 12:45 to do it. So I'll give you guys 15 minutes. It's 7 questions, and it is called Skew Lines 1 through 7. So I'll let you get that open, and then we'll get started. Skew Lines 1 through 7. So I'm going to stop screen sharing and I'm going to put you guys in breakout rooms. And you're doing skew lines 1 through 7. All right, there you go. So in your breakout rooms, you're doing skew lines 1 through 7, and I'll give you until 1:45. So if you're not in your breakout room, you need to go to your breakout room. Tiffany, go to breakout room, kiddo. Tiffany. All right, I'm gonna go ahead and put you in. Oh, wait. If you are watching the pre-recorded version of this, you can go ahead and pause it. And then once it's over, just fast forward until the end of this. So if you're watching the recording, go ahead and pause it. I'm going to shut my video off. That way you know like how long you have to fast forward whenever you're done. All right, guys, welcome back. I'll give you a minute to come back and then we will go over these questions from your knowledge check and then I'll let you go. And answer any questions that you have, obviously. All right, I'll give you guys about 30 seconds. There's like 2 people left in breakout rooms, and then we will go over these. All right, here we go. So the first question are lines A and B skew.
Are lines A and B skew? Why, yes, they are, because as you can see, they're not coplanar, they're in different planes, and they don't intersect.
So you may have, and let me go back to the notes. You may have felt like they weren't skew, but if you notice, see how this is like, let me get a pencil. See how this right here is dotted? It's kind of like if you took a piece of paper and then you shot a line through it. So one of them's going through it and then one of them's like going across it, which is what makes them skew. How many lines can be drawn through point C to make it parallel to A and B? Oh, dang, I hit the wrong button. Sorry, guys.
How many lines can be drawn through the point C that are parallel to AB? The answer is exactly one line, and it looks like this.
So questions about that? Okay, now I gotta go back and slide through all these. I'm so sorry. I was getting really good at hitting the correct button towards the end of the semester, but sometimes these are a little hard. All right, question 3. Which lines are parallel to EF? So one of the easiest ways to look at this is to actually highlight EF and then going through and finding which ones are parallel. You can really just kind of go around like this. And all of these are the ones that are parallel. Let's see what she has to say about that though. Hopefully I can hit the right button this time. Yes.
Which lines are parallel to line EF? So EF is here. So where are the parallel lines? Well, HG, AB, and DC are all parallel to EF, and that is HG, AB, DC. So 1, 3, and 5, which is answer C.
All right, questions on that? I think that you guys are probably professionals right now at this point with parallel lines. Which ones are skew? Skew means that they're not parallel, they're not perpendicular, they're not touching, and they don't make any sense with each other. So here goes skew.
Which lines are skew to EF? All right, so we have a line here. Here's EF. Now, which lines are skew?
Her lines are way straighter than mine.
BC. BC is definitely skew. We have HD. That is skew as well. DC is not skew, it's parallel. So not DC. AB is also parallel, and CG, that is also skew. So we have HD, BC, and GC or CG. 1, 2, and 5. That is answer D.
Okay, questions on that? So skew, remember, it's not parallel, it's not perpendicular, and it doesn't make any sense with the other one. Two intersecting lines are always coplanar. Oh, I hit it again, sorry.
True or false? Two intersecting lines are always coplanar. That is true. If you have two intersecting lines, you can always draw a plane that contains both of these lines. So this is true.
Sorry, now I gotta backtrack again. I'm sorry, guys. Give me a week and I'll be back in the groove, okay? Wait, we did two, no, okay, good. All right, we got this one.
True or false? Two skew lines are coplanar. This is false. By definition, skew lines are not coplanar.
All right, and last question. Complete the statement with the most appropriate word. Two skew lines are blank parallel. I think this one should be a really easy one for you guys.
Complete this statement with the most appropriate word. Two skew lines are never parallel. Otherwise, they would just be called parallel lines. So skew lines are never parallel.
All right, questions on any of these or questions on anything that we went over today? Anyone?